Is it possible to detect an iron deficiency in blood using chemoluminescence? I put quotations around the word blood because since we can't use actual blood because that would be unethical, we had to use a blood substitute using corn syrup, flour, and other substances along by putting in iron filings. So that way we could actually control the amount of iron per blood sample. Hello? The question explored. The chemical substance luminol has the ability to glow when it comes into contact with certain agents. In this case, the iron will act as a catalyst. Depending on how much iron is in a certain sample of blood, the luminol will actually go brighter since the higher amount of iron will catalyze within the luminol. This method could be used to determine whether a patient is at risk or has iron deficiency anemia, depending on how bright the substance glows. This adds to other ways to diagnose the condition, since at the moment there are somewhat effective ways, but since anemia or iron levels in blood can fluctuate, it's very hard to diagnose anemia. The science behind it is the chemical substance in luminol that reacts with the hydrogen peroxide, as seen in the picture here. It's gonna remove the iron and then oxidize the chemicals in the luminol to make it glow. In this case, the iron will allow the chemical reaction to speed up since it acts as a catalyst for oxidation. The materials we used are a light meter, some small cups, liquid measuring cups, luminol, powdered luminol, sodium hydroxide solutions, a spray bottle, an empty spray bottle, hydrogen peroxide solution, iron filings, flour, water, corn syrup, red food dye, potassium ferrocyanide. So basically, first you have to make the blood by mixing the water and corn syrup and the red food dye. We didn't want to use straight corn syrup because since in the real world you're not going to be testing clear blood because that's not realistic. We had to put something to either to dim the lighting of the luminol, and so that's how you make the blood. And then after that you make the luminol solution with hydrogen peroxide and potassium ferrocyanide in another cup, and then you pour both the substances into a spray bottle simultaneously, so that at the same time you just start the reaction, because once it starts, it's going to keep going. And then you spray the mixture into each cup of blood, and then you wait 3 minutes, turn off the lights, and then use the light meter to measure the brightness of each blood sample. Record results. Yeah. Our hypothesis was, if there is a direct correlation between the amount of iron present in the blood and the luminosity of a blood sample after the luminol mixture is applied, then the use of chemoluminescence should be a viable use for detecting iron deficiency anemia, since the iron acts as a catalyst and will make the reaction happen faster. Here's our data. As you can see, we used 3 sets. One for the that is comparable to an average amount of iron per milliliter of blood in a normal human. Set 2 is lower than average amount, and then 3 is a very low average amount or borderline anemic. Here are my charts. Here are the 3 charts for each set. This one, they should be around the same amount. And then when you combine all 3 graphs, you can see that there's a somewhat linear relationship between the brightness and the amount of blood used. Our conclusion was that there is, while there is a correlation between the iron content and brightness, the ability to detect whether a sample was anemic or not was inconclusive, because in the real world, differences like this are so minute that there's almost no discernible difference. Based on these findings, we concluded that our hypothesis was partially incorrect. While there is some correlation to the amount of blood versus brightness, the difference between sets. Our possible errors that could have happened in our experiment was inconsistent amounts of blood per sample. This could be fixed by not using the spray bottle. We wanted to use the spray bottle because it would reduce the amount that we used, but we figured that next time, if we did it again, it would be easier to redo the reaction multiple times. Our second error is the blood samples could have been made with varying amounts of ingredients. We could fix this by making one big batch. Our mistake was the first time we tried to make a batch, we figured that we did not have enough ingredients, so we had to drive back to Home Depot, get all the ingredients again, and we had to make a second batch, and this could have caused some errors. And the third one was having the light meter at the correct angle each time. Since the cups were very tall and the amount of sample blood we used was a bit smaller, it was very hard to angle the light meter at the exact same angle every time. So we figured that an easier way to do this is to actually either use a plate or cut um cut the cup so that it's almost exposed like a bowl, and that's it.